So today we are going to work out with LDR, which you can see now in the zoomed way, and here you can see the doping of CDS material, and these are the connectors over which there is a cover, transparent cover, which helps to transfer the light, and then the resistance of this material is going to change. So let us see how this fellow respond with respect to light. So let us create a working circuit for this model, for the sensor. So first of all, we'll try to observe that how its resistance is getting changed with respect to light falling onto this one. So what we will do here, I have connected the two connections of multimeter here, and going to sense the resistance across this in different conditions. So now you can see that I have put this fellow in the multimeter. Okay, and now let us switch on the multimeter and see what is the reading coming. So I am putting it on resistance value. So now you can see that at this condition the resistance is coming at 4.86 kilo ohm, and now I am trying to cover it, okay, and see what is happening. The moment I try to cover it, shadow, correct, so you can see the resistance is changing, and actually it is increasing. When I totally expose this to the light, which is a tube light now, so it is 4.89, and the moment shadow is coming over this one, you can see that resistance is changing, and that change in resistance is not very instant, but it is quite sensitive, and it takes some time to change. Let us do it again. Covered totally, and now you can see that some static value is coming, and then when you open it, the value is getting changed. So let us see when I'm trying to totally cover it and see what is the response time to get a static value. So now let us cover it roughly. So I have totally covered it, and you can see that resistance is still falling. So now it is little bit .4, 40.3. So 40 kilo ohm you can say is the resistance value in dark, and in light you can see the response time 4.9. So in this light condition it is 4.9, and then when I cover it, it takes some amount of time to go to this value. Now exactly at this point I'm going to expose it, and you can feel the response time. Yeah, so it has almost quickly come, even though some time was required. Now we'll do a basic experiment over this one. We'll try to make a distance or range sensor with respect to this one. So similar to the previous experiment, I have prepared some physical model here which helps me to create distance variation. So let us see what are the different things we have today. So I have taken the same circuit which we have taken earlier. So 330 ohm resistance is there, 330 ohms resistance, and then I'm going to connect it with power supply. So I'll connect it with power supply, and these are the connections coming out for power supply. So negative I'm connecting here, and positive I'm connecting here. This is just 5 volts, and here I'm going to put small LED which helps me to create a source of light, and that's how we inserted. And let us switch on. There is no complicated circuit till now. This is 5 volt. This is 5 volt. Switch it off. Now with respect to this, we wanted to note down what is its performance. So what I have done here, I have taken it, let us make it here, try to put it here, and keep these two in front of each other so that you can make an optocoupler the same way we have made it for photodiode. At the same time, we would like to know what is the resistance value changing. So I have just inserted it and switch on the value of resistance. So now it is 6.87 kilo ohms. Now let us start with 0 volts. I have given the power to this system and it is 0 volts now, and I'm going to slowly increase this. Probably you'll be able to see. Okay, leave it. So I'm going to slowly increase this power of this LED, and it will slightly. So now it is dark. Again, you can see it is 7.31, and I am increasing the voltage value, and LED has started glowing. It is if I tell you the voltage value, it is exactly 2 volts now. Nothing is happening, and the moment I move it little bit more, 2.2 volts started, LED started glowing. The resistance can also be seen here. I would like you to see the voltage value also. In order to see the LED glowing and its effect only, I have switched off the environmental light, and here you can see the LED glowing slightly. You can see that it's slightly started glowing, correct? And you can see the resistance value is coming down. So what we need to do here, now you need to see what is the voltage and how is this changing with respect to the voltage value. You probably may not see exactly the value of like the effect on LED. So now it is exactly 2, and at 2 you can say the value is 41.3 or 40 kilo ohms. Okay, when the LED is kept at 3 volts, it is reduced drastically, 1.48 kilo ohm. So approximately 40 times or somewhere 30-35 times reduced. Then we further increase the value of the voltage. Let us make it 4 volt. So at 4 volt it is less than half, 0.923 kilo ohms, correct. We'll go up to 5 volts. So let us slightly increase the value, 5.0 volts. So it is 7.68. And if at this position, if you would just slightly try to make some different orientation, you can see the value will be further increase. So now it is almost touching this fellow, it is almost touching. So at this stage the value is totally increased. Now in order to do it for sensing the distance, what we will do here, we have taken sleeves, the 2 sleeves we have taken, which we have taken earlier also. So now in the presence of light, you can see it, this is the value. So what we will do now, we have taken the 2 sleeves which we have taken earlier. Let us switch off the power and let us work out the other model which we have prepared. So here I have 2 sleeves, correct. This is not required. This is one hollow sleeve which we have experimented in the previous class, okay. And then here at this end I have attached the LDR. You can see the LDR stated here, and exactly here I am leaving it. And this is a scale which is attached to this insertion rod. At the same time I have prepared a LED setup which will go inside this, correct. So this is the LED setup which will go inside one side of the sleeve, and then we can measure the value of the distance versus the resistance. So let us do it. It's very interesting experiment where we try to develop a sensor. So I'm going to insert here. Let us insert here. So this one I have inserted here, and if you try to see, this is approximately equal to this one, or approximately 3 centimeters, at which we have a light source. So I have inserted it here, okay. And then at the other end, from the other end, we'll try to push this fellow inside. So we need to powerize this LED. So I'm going to connect it. The red wire is positive and the black wire is common. So I have inserted. Let us check whether LED is working or not. Switch it on, and you can see that LED is glowing inside, and the voltage, let us keep at 5 volt. So let us check the LED first. I have inserted in the proper place, and when you switch on, it is properly working. And now let me insert it. So I have inserted it here and checked it out. It's working. Now this has got LED, LDR, fine. So I'm going to insert it here, and this connection is given here, okay. There is no difference in as an cathode and anode, but we have just given it to black and red color. And this I am going to connect with the multimeter, okay. So let us have a connection with multimeter, black and red. and then we will see the distance wise reading. So here we go, we have everything set. So let me switch on. Okay, you can note down the readings. Resistance value. So in the light now you can see it is 3.8 kilo ohm, and if I cover, it's going to be increased. Fine, 140 and so on, because it is properly covered. In the previous one it was only covered from front. So this is the different LDR. Now I'm going to insert, and this distance can be noted down as 30. Okay, 30 centimeter. This is the reading coming, and then this is 30 centimeter. Yeah, this is 30 centimeter, and the reading is 4.47 kilo ohm. Then this is 29. This is 29. Now I'm slightly increasing. 28, not increasing, decreasing the distance. 28 centimeters. 27 centimeters. 26. 25. 24. 23. 22 centimeters is the distance from light source to the LDR. It is 22 now. 21 now. Slight change. 24.42 kilo ohms. 20 centimeters now. 19 centimeters. 18 centimeters. So in this experiment I am doing it very slowly so that you can easily note down. 17 centimeter. 16 centimeter. 15. 14. 13. 12. 11. 10. You can see it is now approaching to some few kilo ohms only. 9 centimeters now. 8 centimeters. 7 centimeter. 6 centimeter. 5 centimeters. 4 centimeter. 3 centimeter, 2 centimeter, 1 centimeter, and 0 centimeter. It's touching. Okay, beyond that, if I do, this will go back and the LED will push it from the other side. Okay, so this is the final reading at 0 centimeters. One important thing I wanted to show in this video, that here we have left the reading in the previous experimentation. We have just left it here and power was on. Okay, now I'm going to switch off the power of LED, so it will be totally in dark. This LDR will be in dark, and let us see what is the resistance coming. So I'm going to switch it off. It's switched off, and you can see that it is approaching to mega ohms, and that's all. Very high resistance value, very high resistance value. Okay, almost working as a insulator. Okay, and when I again switch it on, just now switched on, and you can see this is what we have obtained. Now I'm going to reduce the voltage supply to this fellow, and then you can see that how the values are changing. So I will keep it such that you can see both. So you can now see the multimeter as well as the power supply 5 volts, and then you can see that in dark, this you can note down. Okay, this can be noted down because this is with respect to the intensity of light in dark. Okay, so 5 volt is the LED input. Now I'm going to reduce it to 4 volts, and it has increased 1.2 kilo ohm. Then again I'm making it to 3 volts. You can see that at this instant of time, this is the only source of light. Okay, so let me make it exactly 3. Now it is through 3 ohm, so it has moved from 1.2 to 2 kilo ohm, increasing. Let us make it to 2 volts at, this is 2 volt, it's 13.9. so you can see there is a huge difference. Now let us make it 1. So at 1 volt it is getting stabilized. Okay, so probably the LED is not glowing because we have seen that it started glowing from 2 volts. So now it has started working. So 12 volt we have seen earlier, so that's what is coming, because this what we see is not the exact value. The decimal values are not shown here, so that is why you see a variance in the voltage value. Now resistance value. So this was a resistance value. It will not be helpful for controller work, so we have to convert it to voltage value. So how do we do this? So we'll try to make a ballast circuit. Okay, so in that way, in that circuit, what we will do, we'll connect a resistor here. So now in the dark you can see the resistance is very high, so I will try to take the equal resistance here so that the voltage is getting divided in half and half part. Okay, so I'll try to create a ballast circuit with this one, and then we'll try to measure the resistance here. So I have taken a resistance of 10 kilo ohm, which let us measure and see. This is a 10 kilo ohm resistance, so you can see its value around 9.8 kilo ohm resistor is there, and with which we are going to make a simple bridge. Okay, so how the bridge will be constructed? So I will connect two resistors. This end is for LDR. Okay, so both I am going to connect in series. For this circuit you need to create, I am just showing you the rough circuit, and you have to make a formal circuit in symbolic form and show in your report. So this I have connected. Okay, one resistor here, another resistor here. So now it is reading its resistance, and then I am using another power supply which I am going to connect here. Okay, ground here and positive here. So this is the power supply across these two series of resistor. Okay, so this is across these resistor. Here you can see this is power supply from here to here. This is one LDR, and here you have a fixed resistor. So now I am going to measure the voltage across this resistor. So I'll keep it here and switch on the system. At this instant of time you can see that the setup is still connected like that. This is the power going to the LED, and this is the power going to this particular bridge. Now the output will come in terms of voltages. So I switch it on, and you can see that the power supply to this circuit is approximately 5 volt, exactly 5 volt to this power supply which is going into this circuit, and in LEDs it is 5 volt which is going into the LED. Okay, so LED is glowing with 5 volt, and this circuit is having a power of 5 volt. Both are 5 volt. Now let us see, do we find any good value? So this is when the distance is 0. Okay, let me increase the distance and note down the voltage value. So we'll do it in a reverse way. So this is at 0. Okay, 0 centimeter. First of all, let me see whether our LDR is placed properly or it has disturbed. It has gone little inside. Yeah, fine. So this point here, it is exactly coming. Now you can note down these values. This is now at 30 centimeter now. 0.9 volt. Okay, 29. Let us see first of all, do we get, yeah, we get a nice change in voltage which we can utilize for control purpose, and now it has hit. Okay, so let us measure. At 8 centimeter we are getting 3.3. let us move it and move back and see whether we get the same or not. Again, yeah, you get approximately 3.3. yeah, so again if you take it out and insert at 8 centimeter, yeah, so I was checking the repeatability of this one. So repeatability is good. Now let us take the reading from 0 onwards in the reverse way. So this is 0 centimeter, 4.66 volt, 1 centimeter, 4.54 volts, 2 centimeter, 4.41. This is 3 centimeter, this is 4, 5, 6, 7, 8, 9, 10, 11, 12, 'I want you to see the numbers directly. Let us start with 10 centimeter. You might have noted down it was 2.9 previously at 10 centimeter. Now I am slowly moving it out. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, and 30. And when you switch off, actually we wanted to switch off the LED only. So when the light source is switch off, it is now at 0 volt. So you can see that since it has acted as a insulator, you won't get any voltage throughout. Okay, at 10 centimeter, if you remember, we were getting 3 volts. Fine. So let me restart and check. This is 5 volts again, and you are getting 3 volts. Fine. So it's good, repeatable. So one thing more we can see, what happens if we make it by 1 mm slide or half centimeter. So 10.5. So here it was 3.05, 3.14, and you can see that for each mm you get some value. But that is in terms of millivolts. So now if we increase the voltage supply, let us see what is happening for each mm of change. So I'm making it to 10 volts. Now it is exactly 10 volt supply to this circuit, and let us see. At 10 centimeter we were getting 3, and now we get double. Okay, so everything is fine, there is no issue in the circuit. Okay, now you can see that what are the two other values at 10 here. Did you remember what was the value at 0? It is 9 volt, and at 30 let us note down the value at 15, 4.35, value at 20, 3.13, value at 25, 2.32, and at 30, 1.76. Now I'm going to reduce it to 5 volt and you should get the previous one. So it is now exactly 5 volts. Okay, so this is quite useful sensor where you can sense the value even in mm's, but the only issue is we need to separate out, isolate from the environment light. Okay, let us see is there any effect of environment light. So I'm making it again at 10. Again I'm making it at 10 and it is evening time and it is again at 5. So I'm going to switch it off and then we would like to see that whether we have any change with respect to this. So you may not be able to see, but let me check. It is exactly 3 volts now. It means whatever we have developed is not getting disturbed by the environment light. Okay.